Hello and welcome. Today we are diving into CBSE Class 10 Mathematics, Chapter 5, Arithmetic Progressions, and we're going to focus on a really neat part of it, how to find the sum of all the terms.
We're from the Roy's Academy faculty team, and today we'll learn all about the sum of terms in arithmetic progressions. Now, for obtaining similar video explainers, please connect with Roy's Academy at 8910890311. I'll repeat that number again, 8910890311. Our other number is 8910600503, and again, that's 8910600503.
All right, let's kick things off with a little story. Let's imagine a mother named Shakila. For her daughter's very first birthday, she puts 100 rupees into a money box. The next year, for the second birthday, she puts in 150. For the third, 200 rupees. You can see the pattern here, right? She plans on doing this every single year. So here's the big question. When her daughter finally turns 21, what's the grand total in that money box? Now, we can see this is a perfect arithmetic progression, but adding up 21 different amounts of money, well, that just sounds like a lot of work, doesn't it? I mean, sure, you could sit there and write out all 21 numbers and then add them up one by one. And yeah, you'd get the right answer eventually. But gosh, that would take forever. There's gotta be a smarter, faster way to do this. And lucky for us, there is. And this amazing shortcut was figured out by a 10-year-old boy who would grow up to be one of the greatest mathematicians ever, Carl Friedrich Gauss. The story's pretty famous. His teacher wanted to keep the class busy for a while, so he gave them what he thought was a really tedious task. The challenge was simple. Add up all the whole numbers from 1 all the way to 100. The teacher probably thought he had a good hour of peace and quiet ahead of him. But to his absolute shock, young Gauss shot his hand up with the answer almost immediately. How on earth did he do that? Well, this is where the genius really shines. Gauss first just called the sum S. Easy enough. S equals 1 plus 2 plus 3, and so on. But then he did something brilliantly simple. He wrote the exact same sum right below it, but backwards, starting with 100 and going all the way down to 1. This one little move changes everything. Then he added those two lines together, pairing up the numbers. And here's where the magic happens. Look, 1 plus 100 is 101. 2 plus 99 is also 101. 3 plus 98, yep, 101 again. Every single pair adds up to exactly 101. And since there are 100 numbers, or 100 pairs, the total of these two lines added together is just 100 times 101. But hold on. That big number, 10,100, is for two of the sums added together. It's 2s. So to find the original sum s, you just have to cut it in half. And half of 10,100 is 50/50. A problem that should have taken ages was solved in just a few seconds. You can see why his teacher was speechless. Okay, so that was a super cool trick, right? But it's actually way more than just a trick. The real power here is that we can take this exact same idea and build a universal formula that works for any arithmetic progression. So let's do that right now. So let's imagine any AP. We use A for our first term, D for the common difference between terms, and N for the total number of terms we want to add up. And as we already know, that very last term in our sequence is always A plus N minus 1 times D. Okay, time to pull a Gauss. We're going to write that same series out again, but completely in reverse. So the last term is now the first, and the first term is now the last. The total sum is still S, of course. We've just flipped the order. And just like before, we add our two lines together. Check this out. The first term, A, plus the last term, A plus N minus 1 times D, gives us a total of 2A plus N minus 1 times D. And the amazing part is, just like with Gauss's numbers, every single pair you add up gives you that exact same value. And since we have n pairs, our total for 2s is simply n times that value. So if 2 times our sum is n times that whole expression, then our sum, s, must just be half of that. And there it is. That is the powerful universal formula for the sum of the first n terms of any AP you can think of. This is the amazing tool we were looking for. All right. Now that we have our awesome new formula, let's circle back to Shakila and her daughter's money box. We can totally forget about adding 21 numbers by hand. We can nail this in one clean step. First things first, Let's figure out what our variables are. Okay, so the first term, A, is the 100 rupees she started with. The common difference, D, is that 50 rupee increase she adds every year. And the number of terms, N, is 21 for those 21 birthdays. The only unknown is the total sum, which we call S sub N. Now, we just plug these numbers right into our formula. We get 21 over 2 times 2 times 100 plus 20 times 50. You do the math and bang! The final sum is 12,600 rupees. So much faster than doing it by hand, right? That formula just made our lives a whole lot easier. Now, the formula we just used is an absolute workhorse. It's fantastic. But it has a sibling. There's a slightly different version that can be a real game changer in certain situations. Let's check it out.
The formula on the left is the one we built. It's your go-to when you know the first term A, the common difference D, and how many terms N you're dealing with. But look at the one on the right. If you think about it, that whole chunk, A plus N minus 1 times D, is just the last term of the series. If we call that last term L, our formula simplifies down to something beautiful. N over 2 times A plus L. This is a fantastic shortcut if a problem gives you the first and last terms right away.
So far, we've always been trying to find the sum. But what if a problem flips the script? What happens if you are given the sum, but you have to figure out how many terms it took to get there? Let's try one just like that. So here's the puzzle. We've got an AP that starts at 24 and goes down by 3 each time. We're told that the sum of some number of terms is exactly 78. The question is, how many terms, N, does it take to get that sum? Well, when we plug in everything we know, our A, our D, and our Sn, and we rearrange the formula, we actually end up with a quadratic equation. And when you solve that, you get something weird. 2 possible answers for N, 4 and 13. Wait a minute, how can there be 2 correct answers? This is where it gets really, really cool. If you add up just the first 4 terms, you get exactly 78. But as the series keeps going, the terms eventually go into the negatives. And it just so happens that if you add up all the terms from the 5th all the way to the 13th, the positive and negative numbers in that block perfectly cancel each other out. Their sum is 0. So the total sum is 78 after 4 terms, and it's 78 again after 13 terms. Both answers are right. And that brings us to one last really powerful thought. We've seen how all the individual terms build up to create a sum. But can you go backwards? Think about this. If I tell you the sum of the first 10 terms, and I also tell you the sum of the first 9 terms, what's the only thing that's different between those two totals? It has to be the 10th term itself, right? It's a beautiful, simple connection that shows how the sum of the whole is directly tied to each of its individual parts. This was an initiative from the Roy's Academy faculty team, and today we've learned about the sum of terms in arithmetic progressions. For obtaining similar video explainers, please connect with Roy's Academy at 8910-890311. Repeating the number again, 8910-890311. Our other number is 8910-600503. And again, that's 8910-600503. Thanks so much for joining us.